Alright guys, today we're in section 8.2, the product of powers property. So yesterday we introduced the concept of exponents, and we just more or less reviewed what you've learned in the past about repeated multiplication and evaluating exponents. This chapter is no calculator, so you're not going to see necessarily huge numbers to evaluate, but you will be tested on whether or not you can apply the rules of exponents and their properties. So in this section, at 8.2, we're learning what's called the product of powers property. Someone tell me, what operation is product? Is it addition, subtraction, multiplication, division? What is it, Eric? It's multiplication, all right? So this is also something we touched on yesterday. Addition and subtraction does not apply to exponent rules. It has to be multiplication or division. All right, so product of powers property, what is it? Well, my rule says to multiply powers with the same base, I need to add the exponents. Add the exponents. So the key here is that you have to have the same value as the base, or of your bases. So it needs to be either the same number or the same variable, and when you have that in place and you're multiplying, you can then add the exponents. All right, so what I want you to do is write down that rule, write down all 6 of these examples, skip like 2 lines in between each one, and we're going to evaluate these. So same base on the first one, 3 to the 5th power times 3 to the 8th power. Because they both have a base of 3, we can add our exponents. I am asking you to show that step where you write the same base, the common base, and then you just put 5 plus 8, which equals 3 to the 13th power. And that would be your answer. Okay, you are not evaluating these. That is your answer. All right, now I want you to do the next one. 2 to the 4th power times 2 to the 5th power. Show the step in between what you're adding, and then box in your answer, please. 2 to the 4 plus 5 is 2 to the 9th power. Very good. All right, let's look at the next one down. Negative 5 times negative 5 to the 6th power. There's a couple things we need to look at here. Here, what is different about our base versus the first two? Our base is negative. So the parentheses are really important here, that we keep them in parentheses. And now we need to talk about the exponents, because notice on the first term, there actually is no exponent value written. All right. Does anybody remember, just based on past knowledge, what is actually there if nothing is written? There is a value there, and that's important. What is it, guys? Tell me. It's an understood 1, not 0, but 1, because a 0 for an exponent, as we will explore later on, will totally change the value. So you just need to understand that there's an understood 1 there. So it's negative 5 raised to the 1 plus 6, which is negative 5 to the 7th power. We are not concerned with multiplying these or evaluating them. All we are doing is simplifying the exponents. Okay? So now let's look at the next one. X to the 3rd times x to the 7th. Does everybody agree that even though it's a variable, it is the same variable that is the base? So because we have the same variable serving as the base, we can add the exponents together. 3 plus 7 is 10. All right? I want you to do the same thing on the last one, and then we'll come back to the middle one. Z times z to the 12th power. All right, so we have z times z to the 12th. Z raised to the, did you remember the 1? Yes. Z to the 13th power. Sometimes I put the little dash through the z just to make it look more like a z and less like a 2. Just, you know, obviously we know that's a z. All right, z to the 13th. So now let's look at the fraction. All right, initially when we look at this, it looks difficult. But actually, it's not difficult. We just need to look simply at the base. Are my bases the exact same? Yes. Are they the exact same? Yes. They are both negative 1/2. You must keep it in parentheses. And then you can add the exponents because it is the exact same base in both terms. 3 plus 6 is? 9. and we're done. Okay? So product of powers, the key is, has to be the same base. All right? Has to be the same base. So I'm going to give you now, are you guys done writing down that problem? Okay? I'm going to give you two expressions, all right, that I want you to write down underneath this example. I'm going to give you 6 to the 4th times 5 to the 5th power, and I'm going to give you 3 to the 3rd power times 3 to the 7th power. All right, you have two options here. One of them you can apply the product of powers property, and one of them you cannot. Okay, so I want you to solve the one that you can and tell me why you can't use product of properties on the other one. Okay, so it's a yes or no. If it's no, tell me why not. If it's yes, go ahead and evaluate that. Someone raise your hand and tell me which one was yes and what was the answer. Which one was yes and what was the answer? Mason?
3 to the 3rd power and 3 to times 3 to the 7th power.
Okay, yep, it was. And then what was my answer?
3 to the 10th power.
3 to the 10th power, and I could evaluate because it was the same base. All right, so someone tell me why not on the first one. Someone give that to me, Trey.
No, because the bases are different.
No, different bases. Very simple explanation. You don't have to go into any more detail than that. There's different bases, so you cannot use product of powers property. You're not going to see a ton of this, okay? Because obviously if I'm testing you on your ability to evaluate, I'm not going to give you 5 problems that you can't solve, okay? But you might have a random question like that where I tell you, you make up your own expression that, and we'll talk about this at the end of class, but make up your own expression where you could use the product of powers property to solve. All right, so yes, all right, so that's it for example 1. Let's move on to example 2 now. Finding a power of a power. So now instead of having 2 separate terms with the same base, now I have one term raised to a power, and then also that power is raised to a power. All right, I know if you say that like a bunch of times, it starts sounding confusing. So go ahead and just write down each of these 4 terms. Give yourself about 2 spaces in between, and we'll evaluate these in just a second. Okay, so again, a power raised to a power, it's just going to be a slightly different rule here. Okay, 3 to the 4th power, then raised to the 3rd power, I am going to multiply my exponents. So that equals 3 to the 4 times 3, which is 3 to the 12th power. And that is my answer, 3 to the 12th power. Okay? So now the one directly below it, okay, we're going to apply the same rule even though it's a variable. So let's look at the one directly below. W to the 5th power raised to the 4th power. W to the 5th power raised to the 4th power. All right, why don't you go ahead and write down what you think is step 2. W to the 5th power raised to the 4th power. Did you write W to the 5 times 4? Okay, which is W to the 20th power. I do not care about evaluating. I couldn't anyway because I don't know what W equals. I'm done. All right, I want you to do the top right one on your own. Y to the 2nd raised to the 4th power. Are you kind of catching on to that vocabulary too? How I say raised to the, and then whatever the exponent is, and I say power. Okay, so that's the way I want you guys to talk to in your responses, and when we're, saying answers, that's kind of how we would word it. Does anybody have the answer? Anybody have that answer? Jace, what'd you get? Okay, so let's talk about the parentheses. I only need it when my base is negative, okay? So even though it's in parentheses, it's only in parentheses to separate my powers. Otherwise, it would look like the 24th power. So when I actually write my answer, I don't need the parentheses because I've already multiplied. Okay, so y to the second times 4 equals y to the 8th power. If my base was negative, I would need the parentheses. Okay.
Allow it with parentheses or not?
What now?
Would you still allow it with parentheses?
You just don't need them. You don't need them. I just try to make a habit of writing them without, unless the base is negative. All right. Ethan, you have a question or? Yeah. What's up?
Could you have like more than like 2 powers, like on that last one?
Well, let me explain that one, and then I think I know what you're asking. Let's get to the next example. You're not going to keep raising powers to powers like over and over again, okay? We can raise a power to a power, and that's kind of where it stops. Now, what do you notice about the last problem? What do you notice about this one? It has a double set of parentheses. Can anybody look at that and tell me why do you think there's a double set of parentheses there, Sherelle?
Because the exponent is attached, or the negative is attached to the base.
Okay, so if -4 was not in parentheses, that negative would not be attached to the base anymore. That's what we learned yesterday. So that's why I have to have a parentheses here. And this second set of parentheses, we actually just talked about this. If that wasn't there, what would my exponent look like? 32. Okay, so that's why we have another set. So really, essentially, all we're doing here is the same thing that we've done on the other 3. That we are raising -4, again, parentheses, attach that negative to the base, and then it's 3 times 2, okay? Which equals -4 to the 6th power. All right, that double set of parentheses was only there because my base was negative. All right, you guys writing these down? Got your answers? Okay, for example 2, finding a power of a power. All right, so here's your first checkpoint. What's up? I meant to, hold on. Okay, here's your first checkpoint. Let's say we have y to the 4th times y to the 10th. And we have y to the 4th power raised to the 10th power. On one of these, you need to add your exponents. On the other one, you need to multiply your exponents. I need you to decide which operation belongs with which, okay, and write your answers. So this is a combination of examples 1 and 2, but remember on your test, it's all going to be combined too. So you're going to have to know, when do you add your exponents and when do you multiply them? Anyone raise your hand and tell me, what did you get for the first answer? What'd you get? Shantanique, did you get that answer? It's y to the 14th power. Awesome. All right. And Ethan, what'd you get for the second one? Y to the 40th power. So are we kind of straight on when you add and when you multiply the exponents? Are we good? Okay, last example. All right, this one I need you to be mindful of the term that you have in parentheses and specifically the instructions, because here we are finding a power of a product. Remember, products mean multiplication. All right, go ahead and write down each of these 4 terms, and then we're going to go back through them and evaluate. Okay, go ahead and write down each of these. You need about 2 spaces in between. Let's look at the first one, 2x to the 3rd power, raised to the 3rd power. I think our initial reaction is, oh, well, it's going to be 2x to the 3rd power, and that's my answer. But that's kind of a pitfall or a trap that we don't want to fall into. We have to understand that we're raising the entire, are you paying attention? We're raising the entire term, which means 2 to the 3rd power times x to the 3rd power. Whatever is inside these parentheses, I need to understand that each individual term inside the parentheses is being raised to that power. And you must write the expanded version of it. but this is not your answer. So in this type of problem, we are going to evaluate what is possible to evaluate. Could we do 2 to the third power?
Yes.
Absolutely. And 2 to the third power is what? 8, and then I just bring over the rest, x to the third. And this is my answer, 8x to the third. All right, now the next one over, 5y raised to the fourth power. It gets to be a little bit of a bigger product, but definitely within our realm of capabilities. I want you to try to do the next one over the exact same way. 5y raised to the fourth power. I'm going to walk around and kind of check how you guys are doing. Okay, so again, it's 5 to the fourth power, which, guys, I'm walking around, pretty much everybody did this by hand. Highly recommend, okay? Don't try to do this mental math. 5 to the fourth power times y to the fourth power. Going back to your calculators, I'm not going to stress you on really large exponents, but you could see something like 5 to the fourth power. I mean, it just takes a couple seconds to work by hand. All right, and we know that 5 to the fourth power, what did we just say? 625 y to the fourth power. 625 y to the fourth power. Now let's look at this bottom left expression. 3xy to the second power. You must remember that this exponent right here is raising each individual term to that power. It's not just tacked on to the end of it. Okay, so this means 3 to the second power times x to the second power times y to the second power. Well, without knowing what x and y are, I can't evaluate them other than just writing x squared, y squared. Okay, but can I evaluate 3 squared? Absolutely. 3 squared is not 6. This is where I see these common mistakes happening because you just see the 3 and the 2 and you think I multiply. 3 squared is what, guys? 9x squared y squared. Bring it all back together, and that's going to be your answer. You must show the expanded form. We call it the expanded form, and then we bring it back together into our simplified form. All right, I want you to try the last one now. 2mn to the third power. I'm going to come check. All right, so you guys did really well on that. Again, I'm looking for the expanded form of it. 2 to the third times m to the third times n to the third. And we just touched on the fact that can I add these two exponents together? M to the third, no. Why? Not the same base, okay? But can I evaluate 2 to the third power? Yes, I can, and it's 8 m to the third, n to the third. All right, any questions? All right, one more slide. Can you use the product of powers property to simplify 5 squared times 6 to the fourth? Your answer will either be no, and then tell me why, or it will be yes, and tell me what the answer is. My answer is definitively no, different bases. There's different bases. Again, we don't have to go into all of this elaborate detail. Just a simple acknowledgement that your bases are different would be fine. The last thing I want you to do is I want you to give me your own example. I don't care if it's a number or a variable, but give me an example of the product of powers property and then answer your own problem that you make up. Okay? So product of powers property, just write down your own. I don't care if it's a number raised to a power or a variable. This is kind of going back to example 1. Just do your own, and then I want you to solve it. Sarah, what did you write? Okay, that would be example 3. That would be example 3. I'm just looking for a basic product of powers property, Mason.
3 to the fourth power times 3 to the seventh power.
Perfect. Times 3 to the 7th power. Actually, a lot of people use 3 for the base, which I think is kind of interesting. But that's awesome. And what did you get? What did you get? Whoa, no sir. Multiplying same bases, what do we do to our exponents? 3 to the 11th power. We'll solve Mason's problem for him, okay? It's all right. It's all right. Remember, we multiply when I'm raising a power to a power. Okay, Jace, what did you put?
5 to the second power times 5 to the sixth power.
All right, times 5 to the 6th. And what did you get?
5 to the eighth.
5 to the 8th power. Let's take one more. Sherelle, what'd you put?
14 to the 8th power times 14 to the 9th power.
Very good. 14 to the 9th power. And what did you get?
14 to the 17th power.
14 to the 17th power. Is it okay that my exponent's bigger than my base?
Yes.
Absolutely. Okay, we added correctly, and that's going to be our answer. And if you understand that, that's everything you need to know for section 8.2.